Hello everyone. Today we'll be having a short webinar on the standard template library. So this is a library that contains reusable and generic classes and functions. It was developed in 1994 by Alexander Stefanov. It implements common data structures and algorithms. And the cool thing about standard template library is there is a known time and space complexity, so you don't have to worry about it while writing your code. There will be no surprises. There are three main elements: containers, algorithms, and iterators. So common containers are array, vectors, deque, set, and map. And a container is like a collection of objects. Next is algorithms. These are functions for processing sequences of elements. So you can use them on your containers and they make your program a lot shorter and easier to read. So some common algorithms are sort, count, max, find. And then is the iterator. They generate sequences of elements and they help you traverse through your container. Other than these three main elements, there are functors and allocators, but we'll be mainly focusing on the three that I've mentioned. To include standard template library in your program, you need to use the header bits/std++.h. Now, coming to containers, these are data structures that can store objects of almost any type. So you can have an int type, a double, a float, whatever. Uh, each container has an associated header file, and you can include them by simply putting in the container name. So containers provide default, overloaded, and copy constructors and destructors, and they include some common methods such as size, which gives you the number of elements in your container; insert, which helps you insert an element into the container; empty, which returns a boolean type as to whether your container is empty or not. You can erase the entire container, you can swap elements, and you can compare two containers and so on. Now, there are three main types of containers. First is the sequence container, and it maintains the order of the inserted elements. So as you insert the elements through the end, the order will remain the same. So an example would be an array, which we've all worked with, but also vectors, deque, lists. Then is the associative container. You can insert elements in a predefined order or in an unordered way, which includes sets and maps. And there are container adapters, which we won't really be going through in this webinar. Now coming to vectors. A vector is like an array, and the main difference is that you can add elements towards the end of the vector, and the size won't be your issue. You don't have to specify the size when you're starting to work with vectors, and it grows and shrinks dynamically at runtime, which means it has a dynamic size. It is a type of sequence container. So to include vector, you just have to give the header file for vector, or you can start with a standard template library, which will give you algorithms and everything that you need to work with. Now, the syntax would be vector, then you give the data type, and then you give the vector name. So here we have a vector called marks, and it consists of elements that are of the type integer, and there are 10 elements which are all initialized to 0. Now we'll come to initialization. To initialize a vector, it is just as simple. You have to put in all the elements in curly braces, and you don't have to specify the size. So in this case, we have a vector of integers called marks, and there are the elements 1, 2, 3, 4, 5 in it. But if you want, you can specify the initial size of the vector. So here we have a vector called temperature consisting of doubles. It has 365 elements and they have all been initialized to 40.0. Now you can add vectors to it. The size does not have to remain constant, but they will all have to be doubles. Now to access a vector element, it is very similar to an array. You can just give the vector name and the index. But the thing with this type of accessing is there is no bounds checking. And since you don't really know the size of a vector, you won't get an error here. If you use this syntax, vector name dot add and then the element index, there will be bounds checking, and in case you're exceeding the bounds, you'll get an error. So for example, we have marks here, which is a vector of integers, and we have to access the marks at 0. So we go from 0, 1, 2, which is the normal indexing as in case of arrays, and we access the marks at 0, which is 90. Now to add an element, we have a cool method called pushback, and you just have to put in the element that you want to push back and it will insert at the very end of the vector. So here in case of vector of marks, we have 180, 76 and we push back 70 towards the end of the vector. So we get 180, 76 and 70. Now there are a few more common methods here. Size will give you the number of elements in the vector. Vector dot begin would give you the first element of the vector, and in this case it's 1. And vector name dot end will give you the location after the last element. So we are not going to be pointing at 3 here. We'll be pointing at this location that is right next to 3. So this. Now we'll come to iterators. These allow us to think of containers as a sequence of elements and can be used to traverse through most containers except stack and queue. They're very similar to pointers in their working, so you can think of it as dereferencing, and you are going through the locations and stuff like that. So the declaration is simple. You give the type of container that you want to traverse through, the scope resolution, iterator type, and the name of the iterator. So here we'll be traversing through a vector of integers. We have an iterator, a normal one, not a forward or a reverse, and then you give the name of the iterator, that is IT. Now you have to initialize the iterator as well. So here we have a vector v of integers 1, 2, 3, 4, 5, and we have taken an iterator IT, which has been initialized to v.begin, which means 1. So this IT starts at the location of 1. And since the syntax is quite long and not very readable, to make it a lot simpler, you can use auto. So this part will be gone. Auto takes care of the type of container that you will be traversing through, and you don't have to specify it. Your compiler will figure it out. So we have auto ID is equal to v.begin. So this again will point to 1. Now, as in the case of pointers, there was pointer arithmetic. Similarly, we have simple operations that we can do on iterators as well. So we have the pre-increment and post-increment. We have decrement. We have assignment, meaning the location of IT2 has been assigned to the location of IT1. So IT1 takes the location of IT2. We can dereference it, and this will help us access the data that is available at that particular location. So now we'll be going for a few examples. So here we have a vector of integers 1, 2, 3, 4, 5, and we are using an iterator here. Notice that I haven't initialized this iterator in the beginning, I have initialized it right in the for loop, which means that it is available only in the scope of this for loop. If I wanted to use it throughout the program, I would have to specify it at the beginning. So here I have an iterator IT. It has been initialized to v.begin, so it points at 1. Now it is less than v.end. Remember, v.end points to the location that is right after the last element. So it points at the location after the fifth element, which is why we have taken less than v.end. If we had made it less than equal to v.end, we would not get the right answer. And then we are incrementing it by 1. Now, inside the for loop, we are printing out the elements. So we have dereferenced the iterator, and it will point at the data, like it'll point at the location, then we can access the data that is at the location. So for example, when it points to v.begin, we should get 1, then 2, and then so forth. So when I run this, I get 1, 2, 3, 4, 5. Now we'll look at another example. Here I have a vector of integers that goes from 1 through 10. And here I have taken a for. So it is a simple for loop. We are starting with I equal to 0, which is v at 0, which means it'll point at 1, and I is less than v dot size. V dot size tells you the number of elements in the vector. So what we want to do is traverse through this and print out elements that are even. So if v at a location I is fully divisible by 2, we get an even number. So if the modulo 2 is 0, we should be able to print it out separated by space. So when I run this, yeah, now we're getting 2, 4, 6, 8, and 10, which are the even numbers in this case. And then we'll go to the final example. Here we are doing the same thing, printing out the numbers in the vector that are even, but here we are using an iterator. So we are specifying the iterator right at the beginning. We are initializing it to the very first element, and then we are using a while loop. So while it is not equal to v.end, which means we are traversing right through the vector, and v.end is the sentinel value. A sentinel value is something that is at the very end, which has no value. So as soon as it sees an empty location, it's going to stop, which is right at the very end. So if so we have used a dereferenced iterator. So if the element modulo 2 is equal to 0, which means if the element is even, we are going to erase it. We're going to delete it from the vector. Otherwise, we are going to print out that element and then we are incrementing it by 1. So it goes back to the vector right at the beginning and it checks again. And we should get all the odd numbers in this vector. So 1, 3, 5, 7, 9.
We'll start this session of lists and deque. Firstly, we'll be learning about lists. Lists are sequence containers that allow non-contiguous memory allocation. When compared to vectors, lists has slow and transversal, but once the position is found, the operations like insertion, deletion, shifting and all is very quick. Normally, when we say a list, it's about doubly linked list. For simply singly linked list, we use forward list. And lists doubly linked list do not have access to the random access. We cannot access it directly. Also, we cannot access the indexes. No indexes can be put in. So this is the insertion. When the position is found and then the element is inserted, after the call of insert, say we want to insert 7, the element 7. So the position is found. We can either insert it before or after the position. So this is the syntax of list: template, class, and then class allocator, class list. T is the type of element contained like integer, character, or it may be user defined type. Alloc is the allocator of the object. By default, the allocator is the class template itself. These are few functions in list. List remove is used to remove the values, and then reverse is the list, which the back comes to the front end and the front goes to the back. Next is the size. It determines the number of elements in the list. I mean, basically the size of the list. List resize is like used to resize the list. Say if the size is 7 and you want to resize it to 9 or something other. Sort is it sorts the list in increasing order. In general, it is increasing order. List max size is returns the maximum number of elements in the list. List unique is removes all the duplicate consecutive elements. Say we have 2, 2 and 2. So it removes two twos. Like if it is 2, 3 and 2, it does not remove. If it is duplicate consecutive, one after the other, the same element, it removes. Next is list emplace front and list emplace back. These functions are used to insert a new element into the list container. The new element is added to the beginning of the list or at the end of the list, namely emplace front and emplace back. List clear is it clears all the values in the list. I mean, the elements are taken out from the list, but not the entire list is not deleted. We have it's an empty list. List operator is used to assign new contents to the list, either replacing or changing. List swap is swapping the contents of one list with another list of same type and size. Say we have a list of 7 size and 7 sizes of another list 2, say list 1 and list 2. So we can swap elements of the list 1 and list 2 if their size and type is same. Type in the sense like both must be integer or character or anything, the same type of the list, and the size must be same. Say 7 and 7, 8 and 8. So list splice is used to transfer elements. Like you can, even if the list, in this case the list size need not be same, you can transfer the specific elements to the other list. List merges, it merges two lists which need to be sorted. And then also list emplace function in STL extends the list by inserting new element. Like say we need to insert a position, we need to insert an element in position 3, where we can use this list emplace function and then specify the position and the element. This is an example, simple example for list. So basically I'm creating a list L, and then L push back 0 is like we cannot access the value directly, no, which has, so no random access to list. So I use iterators. So in general, using for loop is not good practice while list, but since like it's the beginning, we can use for loops to iterate it. Iterators is nothing but it stores a position of entries. Like it's basically a pointer which has address. So it has no random access. So I'm using the function push back, which will insert 0. And then I'm creating an iterator itr, and then I'm putting it inside a for loop, like for loop to find the beginning. L beginning is the beginning value of the first element. L beginning is the first element value, and then L end is the last element. And I want to replace, say, the ninth element. So I'm inserting L insert itr is the iterator we created, and then 5 is the element which I want to replace the ninth element. So 5 will be put on in 9 will be replaced with 5. And then if we can also find the elements using the iterator and erase it, like L erases the element. So I want to erase this 6. So I use L erase function. and then for list operator L begin L end, and then I'm putting it inside a for loop. So that is all about lists. We'll see an example. So in this example, I'm creating a list named my list. Initially it has 5 elements, say like 5 zeros, I mean 0000. List int iterator. Again, I'm creating an iterator, my list, to begin the list. I mean, to start with the list. So if I want to change a particular element, say we cannot use like this thing. This cannot be done in lists where you can specify the address and then do the changes. Since it has no random access or you cannot specify indexes, I'm advancing it where I use the iterator and then say I want to insert. I want to change the position of, I mean, insert a value in the position 2. So I'm inserting 10. So next, I'm like, we can also use the same iterator like star of it, but then I'm creating another iterator output it. So for output it, my list begin, I'm putting it inside the for loop to start the function, and this will give the output. And same here, in case I want to insert, I'm inserting an element 3, I'm advancing it, so we'll see the output here. Yeah. So yeah, this is the output. I created my list, so which has 000, and then I advanced it to 2. This is just to check the list. So then it follows the next operation, insert it 30. Yeah, this is all about lists. Moving on to deque. Deque is doubly ended queues or sequence containers with expansion and contraction both the ends. I mean insertion at both the ends, front and back. It is quite similar to vector, where the variable length is from backwards and forwards. We can also add elements back and front, as we said, but not vectors. Simply shift the element. It's time consuming. That's where the idea of deque comes in. Deque is doubly ended queues. It is different from its deques are basically implementation of data structures. Okay, the data structures of doubly ended queues. Queue allows only insertion at the end and deletion from the front. I mean, you can perform only insertion at one position and deletion at other position. Deques give access to insertion and deletion both front. Deques are less time consuming. The functions are all the same as the vector, but with an addition of push and pop operation for both front and back, where in vectors only front and like front and back can be done separately only, either insertion at the back and deletion at the front or vice versa. So this is the implementation of deque. This is the front and then this is the rear, front and back. You can insert elements here or delete elements at the back, or insert elements at the front and delete elements at the back. These are the basic functions in deque. Like these are the very basic functions. We also have so many the basics we need to know like before jumping on the complicated functions. Deque insert function in C++ STL an element, and it returns the iterator that points to the most. R begin is returns a reverse iterator which points to the last element. Say the last element is 9 and the first element is 1. Deque R begin is it points to the last element 9 of the last place. It's the reverse beginning. So 9 comes in the front and the 1 goes to the back. So it's DQR begin. DQR end is returns a reverse iterator which points to the position before the beginning of the DQ. So before the position of the DQ will be 9, obviously. 9 is before 1, so it points to 9. DQC begin is returns a constant iterator pointing to the first element. So it returns the constant iterator which is point to the first element of the container. That is, the iterator cannot be used to modify it. It is only used to traverse the DQ. Say the DQ is starting from 1 to 9. So this one points to the iterator pointing to the first element, which is 1. DQ max size returns the size, which is basically the number of elements in the DQ container can hold. And DQ assign function is assigning values to the same or different DQ containers. Assign values, like say I want to assign a value at the position 3, so DQ assign is due. DQ resize is you can change the size of the DQ. And then DQ push and push front and push back is like push element in the DQ through the front and from the back. These are push front and push back. Similarly, pop front and pop back are used to remove or delete elements from both front and back. So this is the syntax of DQ. Template, you create a template with class D and then allocator class DQ, and then like we are performing the actions over here. And then so T is the element type. Say any element like integer or character, or you can also put a class instead of an element. I mean, like not necessarily integer or character or anything. You can also put a class inside. This can also be declared without arguments. So this traverses the deque same way as the vector, but it's not time consuming. This is a simple example for DQ. Like here you can see I put on with creating a DQ, my DQ with arguments. This can also be created with or without arguments. Like say you want to give the direct value, so arguments are not necessary. So we can use insert, push back, all the functions insert the DQ. This is a simple DQ. We're just iterating it and then checking the output. We'll see an example of DQ. Yeah. So yeah, I'm creating a DQ. I'm like, we can also create the DQs directly without any functions, but I used a function. Like here we have the show DQ, my DQ, like I mean show DQ, which is the DQ I've created. And then I'm creating an iterator and it starts the DQ, I mean G dot begin. I'm creating the DQ is G and then iterator is it. I'm initializing it with G begin, and then it factorial is equal to G end, the end of the DQ, and then plus plus it C out T, and then moving on to the main function DQ end. I'm pushing back 10. So here we can see created G dot quiz. You can, I'm creating, no, this is the first DQ we have created is G, and then second DQ is quiz. I'm using the member functions push back and push front to insert and delete values and all. So the first thing is push back 10, where I'm pushing 10 to the back and then 20 to the front, similarly 30 and then front. See out, this will give the output of the DQ. We can also get the size and maximum size. Then we can also get the elements at the position, and then only the front part of the DQ or the back part of the DQ, and we can also pop the elements. Pop is nothing but used to delete, where push is nothing but which is the function used to insert elements. Push front and push back, like pop front and pop back is used to delete elements at the front and back. We'll see the output. So yeah, this is the output. The DQ we created this G quiz 15, 20, 10, 30 here. The push function used to insert these elements 10, 20, 30 and 15. So similarly, yeah, 10 back, it is pushed into the back, and then front 20, and then back 30, and then front 15. So yeah, this will be the DQ we created. So yeah, the size is 4. Maximum size we can, in which the DQ can hold, is this random value which the compiler will give. So the DQ at front, DQ at 2 will give the what element is located at that position. So 10 is located from the back. So it is reversed. Okay. Next, the front element is 15 and the back element is 30. Now we are popping the front element, in which pop front, the front of the front is in the sense the first element will be popped out. So 15 is gone and the output is 20, 10 and 30. Next we pop the back element, in which 30 will be gone. So yeah, this is how you perform the actions or operations in DQ. We can also use all the other functions like resize or merge or delete. Push and pop is very important. So yeah, that is all about DQ and lists.
Okay, so basically maps are associative containers that store elements in a mapped fashion. Each element has a key value and a mapped value, and no two mapped values can have the same key value. So these are a few basic functions associated with maps that we're going to see. So one thing that we need to make sure while using maps, and one thing we need to keep in mind, is that all keys and maps are assorted, and usually we look at a few codes here, but however I want to note that to iterate through each element in the map we need to use an iterator based for loop. All right, so the first code that we see here is to basically tell you how to print the elements in a map. So this is the basic syntax that we have to use. So while printing maps, you have to give the map function, and then you have to specify the parameters for the key. So the first parameter here is the key of the map, and the string here is the value of the map. That is the second parameter. So this is the first parameter, first field parameter. This is the second field parameter, and the name that I've given to this map is students. So dot insert basic dot insert function can be used, and we also it is to be noted should be noted that this dot insert function would always return you a pair object value. So we'll get two values over here, that is the key function and the elementary value. You can use a dot insert functions to add values in the maps, or use a square bracket where this area would represent the key and this would represent the second field value. And just for printing it out, use the iterator based for loop. So, and then for C out, use the iterator arrow first. So the first field would be the key value, and the second field would be the elementary value that we propose for this map. If we run this program, this is what we get. So we get the details of the students and the key values and the names, elementary values of the student. Here you should note that the values are always in ascending order. Hence, it is always in a sorted way, and the default value that you are going to get is ascending order. Now, if we go on to the second example of this, so again, the basic syntax that is already there. Now, again, to add values to the map, you can always use a curly bracket, and then within these curly brackets, you can add the key and the elementary values of the map, and then again use a dot insert function, the same for loop based iterator you can use. Now we are here in this example, we are going to see how to update a value in a map. All right, so this is the code for that. So since it is going to return us a pair value and we have to iterate through all the values of the map, all we have to do is return value is equal to student dot insert 6 test2. So it is going to check whether, and each and just as I said, all the values in a map, all the keys in a map are only have one elemental value associated with it. So for example, in this example, 6 test2 is given. However, I have already previously inserted 6 Tina. So if we put a if condition over here and we return the return dot second would represent the elemental value associated with the key 6 in this case that we've taken. So for in this case, if this is false, then it is going to print out fail due to duplicate key. If it is true, then insertion would be successful. If we run this program and see, we'll get fail due to duplicate key. Yes, because 6 Tina is already there previously and hence test2 is not printed. However, if we put 7 in place of 6, we get this, that insertion is successful and test2 value is updated for key number 7. Now going to the third example. In the third example, we are going to take a look into this concept of comparator. Now, just as we saw previously in maths, that it is always sorted, right? And it's always in ascending order. So that is the default way of it being printed. However, if you want to print it in the descending order, you have to include this comparator function, which is a Boolean operator, and then you have to give parameters like int left and int right, because in this case we're using the key values to be integers. So we're going to give int left and int right and return left is greater than right. So for ascending order, right would be greater than left, which is the default parameter, so you don't need to mention it. However, if you want the descending order, then all you have to do is make left greater than right. Then the entire thing remains same. However, this is the print map function that I've given for printing out the iterated for loop for the printing out the map. So in this itself, you have to include Boolean and a function operator or a functor here to link this print map function that we used. And then in that, the integer, both of the parameters for the integer of the comparator should be specified. And after that, everything remains same here itself. Also in the map thing, you have to specify the functors. And then for the students parameter, for students that we've given the name as for the map, you have to include this parameter comparator. And after that, all you have to do is print. Everything remains same. Dot insert. You can use dot insert to print it out. You can use a square bracket to print it out. No problem. After calling out the function, you run the program. You will get a descending order. You get it in 3, 2, 1. Yes. 3, 2, 1. That's how you get it. Now, we go on to the fourth example that we have. So, in this fourth example, everything remains the same. Again, we have the comparator method. So, it is going to print it in descending order. Now, if we want to erase a particular number in map, all you have to do is put an iterator over here and give it a name. I gave it a name it underscore start is equal to student dot find. Now, to erase an element, we first have to try and get a target entry. So in this case, we get key value 5 is target entry. So this is the value that is going to be deleted. Now you use the if condition students.n, which is not equal to it underscore start. So it has to continue all the way. It has to iterate all the way through all the values given in the map. And then you have to put student.erase function and give this particular value and print map. So after deleting, you see that the fifth value is deleted. Now if I want to delete multiple values in a map, So for deleting multiple values, so the same code would be used for this. All I've just given it a different name, IT underscore start student dot find 2. So for this, all you have to do is edit this parameter as IT underscore start and IT underscore end. So in this case, what happens is that all the numbers from 2 to 5 except the elemental values of 2 would not be deleted. Only 1 and 2 would be represented in this case, and 3, 4, 5 would be deleted. Then after calling out the function, you run the program. Yes. So after deleting, this is how we get. So this is how we delete multiple values in maps. Now we are going to take a look at multi-maps. So multi-map is basically similar to mapping itself. However, there's the addition that multiple elements can have the same keys rather than each element being unique. And the key value and map value pair has to be unique in each case. Now, here are the basic functions that are associated with this. So always a pair value is given back when a new element is added. So always a pair object is given back. So no matter what happens, integer value or a string value, so key and elemental value would be provided in the return statement. So here we go on to the first example that we have, which basically is the simple printing of it. So here I've used the comparator method, and this is I have put in the default of the comparator method. So it's going to print it in ascending order only, but I've included just in case. If you don't include this, still you're going to get it in ascending order. So the way we print it is basically the same. You use school.insert and put in the string values for this because in this case we don't have int values, so we have string values, and hence for multi-mapping while defining the parameters we use string and string, and this is how we basically use it to compare the bool comparator. We put in the values for all of this, so we have used multiple elemental values for the same key values. So usually in maps what happened, they don't accept key values for multiple elemental values for key. However, in multi-maps you do. So if we print it out after calling out the function, if we print it out, we are going to get all the values over here. Now, similarly in this case, if you want to make it in descending order, if you want to print it in descending order, all you have to do is make left greater than right and run it. You're going to get it from class 8 to class 6. Yes. Going on to the third example. So here we are going to look into equal underscore range and how to delete keys. So, okay. So this is the code that we have. We use an iterator to print it all up. Now, equal underscore range is going to give us the elemental values of the total elemental values of that particular key. So again, we use a for loop, and in that we use the iterator based for loop, just as we did previously. Point it out to the first field. First field is the key, and the second field would be the elemental value of that particular key that we want to print out. So build and run it. You're going to get total entries 2. We have only 2 entries for this, and it's going to print out the entries for the key value class 6. Now, here is the erase function for class 6 key values. All you have to do is return underscore val for the first key value. The first key value, first field, dot first always represent the key value, dot second always represent the elemental value. So here it would know that it has to delete all the key and the elemental values associated with the key class 6. And just to simply give this function dot erase. Build and run this program. It's going to delete all the class 6 key elements. If we go on to the third example over here, you're going to learn about updation, how to update values in a multi-map. So this is the basic code that we did previously. how to include it all, equal underscore range that we just did. Now, here what you have to do for, now we basically cannot just delete a key and its element randomly. You have to store it in a temporary value, and then from the temporary value, you have to erase the entire thing. So the key and the elemental value totally would be erased, and then you have to use dot insert. So basically, completely new key and elemental value would be introduced. So all you have to do is for map. So what I did previously uh, to avoid writing this entire code multiple times, I just used this type def and I named it mmap. So I stored temp value in mmap. Then I used the iterator based for loop. And in this, I said that if it represent the second element, that is the elemental value, which is 6, then the temp would be stored in it and school dot erase temp. So the entire temp would be deleted. And then in place of that, you have to include school dot insert class 6 music, class 7 music. So in this, what happens is that I have class 6 as the key value. So wherever it finds physics as elemental value in class 6, it's going to delete that. It's going to store it in temp and it's going to delete that. And then in place of that, it's going to include class 7 music. And then after updation, you have to just call the function for print map and run the program. So after updation, here we saw that class 6 had maths and physics, and now we see that class 6 only has maths, and then it is updated class 7 value as music. So this is how we do updation, and with this we come to an end this webinar, and we hope you enjoyed this and found it useful. So thank you, stay home and stay safe.